In the last section, we dealt with solving equations of different kinds. So we looked at solving linear equations, basic quadratic equations, and some square root equations. And in this section, we're going to take away that requirement of equality and talk about inequalities. Okay, so less than, less than or equal to, greater than or equal to, that sort of thing. And in this video in particular, we're going to talk about just compound inequalities, and then in the next video we're going to talk about when we introduce absolute values into inequalities. Alright, so let's go ahead and begin. Here's our first example, and we want to determine the solution set. Okay, typically we will communicate this using interval notation. So remember, this is sorry, not that. We're going to use parentheses. We're going to use brackets. Unions. The other symbol that you might see is an intersection. However, with this symbol, we can always rewrite the set that we currently have. So your answer should never contain an intersection. It can contain a union though. Alright? So let's go ahead and actually work through this one. Solving an inequality is very similar to solving an equality, if we had, say, equals here, except for two cases, and we'll see those two cases pop up here. So let's solve this as we would any other equation. So first, what do? I have to subtract 3 from both sides. Alright, so I get minus 2x minus 1 over 5 less than or equal to x over 2 minus 3. Okay, what do I want to do next? I want to multiply both sides by negative 5. Okay, so I'm going to multiply by negative 5 to this entire side, and then I'm going to multiply this entire side by minus 5 as well. Okay, so let's see, this side, that washes out, so I'm left with just 2x minus 1. Okay, and then on the right hand side, what happens? I get a minus 5 x over 2, multiplying to this one, and then multiplying these two together. Remembering I have to distribute, I get plus 15. Now, here's the first key thing with inequalities. When you multiply by a negative, you need to switch direction of signs. Okay, so this goes to a greater than or equal to. Alright, and then we can continue solving as normal. So I'm going to add 1 to both sides. Okay, and simultaneously, just to save myself some work, I'm going to add 5x over 2 to both sides as well. Alright, and my resulting inequality is going to be, let's see, this is, if I add these together, this is going to be 4x over 2. So I end up with 9x over 2 is greater than or equal to 16. And then I can divide as normal. So since this is positive, I do not need to switch the signs. So I have x is greater than or equal to, let's see, this is going to be 16 times 2 over 9. So let's see, what do I get out? I get x is greater than or equal to 32 over 9, I think, if I'm doing my arithmetic correctly. Verify by a calculator, just to make sure. And now, so this is great. I also want to represent this graphically just so we can see what's going on. Most problems you might not be required to. So here's 0. Here is 32 over 9. Alright, so what is this saying? That x can be any value greater than this, so to the right of this. Okay, so the way we communicate that graphically is, since we have a greater than or equal to, we have a closed dot, and then it goes to the right. Alright, so formally though, our answer will be the solution set is, so even though we have an interval, we communicate it with a set. So we begin by using a bracket, since we have an equal to, and so it goes from 32 over 9 all the way up to positive infinity, and we exclude positive infinity because you can never reach it. So that's the answer to this problem. So what did I do? I went through and did the basic same operations as we did with equalities, remembering that if we multiply and really divide by a negative number, we switch the sign. Okay, go through, solve it, and this part here was extra, and then we wrote our answer out as the solution set is in interval notation. Okay, now if this had been a open circle, if this had been just strict inequality, strictly greater than and no equality, this dot would be open, and we would have a parentheses here as well. Let's see another example. So here's what we call a compound inequality. It's two inequalities in one. Okay, so what this is really communicating is if we want to, we can break it up into two inequalities. We can break it up into 13 less than or equal to 9 minus 4x, and we can also break it into 9 minus 4x is less than 29. Okay, and solve both of those at the same time. What I'm going to do is actually save myself some time and work both of them at the same time. So for example, what would we do to solve for x in these equations first? I would subtract 9, right? So what I'm going to do is I'm going to subtract 9 from all three parts, and essentially doing the same work over here. Okay, so what am I left with? I'm left with 4 less than or equal to minus 4x less than 20. Okay, and what would I do next? Okay, I would divide by negative 4, right? So I'm going to divide by negative 4 to every component. Okay, and my final step here is to rewrite it. So I have negative 1. Now I divided by a negative, so my sign switches. Less than or greater than or equal to x greater than minus 5. Okay, so now on a number line, if I just draw a number line quickly, what is this saying? This is saying that, well, if I put say 0 here, and I have negative 1 and I have minus 5, that I have circles here and here. At negative 1, it's actually filled in, and x can be any value in between. So my final answer here is going to be that the solution set is, and I begin with the lower bound, so I start at minus 5, have a parentheses as it is open, and continue until I hit negative 1, and then I have a bracket there as I have a closed circle, and that's my answer. Okay? So compound inequalities, remember, I chose to solve it by doing all the operations at once. You could, as I mentioned, break it into two separate pieces and work both of them, and you'll get the same answer. You will have to do an intersection, though, okay? Because what you'll end up is you'll get something like this is going that way, this is going that way, and so then you'll have to kind of fill in the dots and say, oh, well, it's going to be everything that's common to both of those, which is this area in between here. Okay, but again, all your answer should be the solution set is, and then your the interval expressed in interval notation. And in the next video, we'll talk about absolute value inequality.